To measure the diameter of a wire, what tool do we need? Exactly, good job. The height of bench, meter rule, the length of the laboratory, measuring tape. Exactly, that is the answer. Correct answer. Question 2. An object is moving with uniform deceleration. Which statement describes its motion? Deceleration, uniform. Uniform deceleration.
B.
No. Deceleration. It means the speed is changing.
Yeah.
Constantly, meaning the same decrease every time interval. With the speed, with the time, the speed decrease linearly like this. And the answer is C. Its speed is decreasing. Please circle that. C. You got it, right? The word deceleration is the opposite to acceleration. When you accelerate velocity like this, accelerate thing, and the downward here is decelerating, decreasing the speed, the velocity. Okay, the decelerating, accelerating. Answer C. Question 3. The graph shows how the speed of car varies during part of its journey. What is the value of the car acceleration between 6 seconds and 10 seconds? You forgot how to calculate it. Oh, you're doing it correct. You know, you can type in like this, 15 subtract 10, and then divided by 4 equal. Yeah.
But I don't have a keyboard, so I think it will take a longer time. So
You're using light finger to write?
yes.
I can recommend you a type pen like this. It's very cheap compared to the Apple Pencil. This thing, basic. It is 1/4 the price of the Apple Pencil, but we still can write very well. It has a palm rejection also. You can put your hand on the tablet. I remember his name. It's not the basic thing, huh? There's another branch. This one. Gen 2 Pro Max, yeah. In case you want to buy a pen which is much cheaper than an Apple Pencil. What is the value of the calculation? 1.25, correct? Well done. Question 4. The gravitational field strength on the moon is less than on the Earth. Which of these is different when done on the moon compared with when done on Earth? What do you think? Gravitational potential energy gained by a stone lifted through the same vertical height. Is it different, the gravitational potential energy on the moon compared to the potential energy on Earth?
No.
Yes, it is different. What is the equation for the gravitational potential energy? M
Oh, M
G mgh, yes. So it depends on this g, which mean g is a gravitational field strength. On the moon, the gravitational field strength is about 1/6 of the gravitational field strength on the Earth. And therefore, the potential energy on the moon will be pretty much lower than the potential energy on the Earth. The kinetic energy gained by a ball when hit the same force for the same period of time is it different on the moon? Kinetic energy hit by the same force related to acceleration by Newton's second law, huh? Acceleration is force divided by the mass, and acceleration will relate to velocity. Velocity is initial velocity. Assume that the object was initially at rest, so the initial velocity is 0. V is a times t, huh? Or we have another relationship also. The force multiplied with the time, which is the impulse, equal to the change in momentum. Anyway, the velocity changes by the same acceleration. The acceleration does not depend on the gravitational field strength, and therefore the kinetic energy that the object obtained when being hit by force F is the same on the moon and on Earth. So same kinetic energy, and we choose which of these different. We've just explained that A is different, huh? Momentum gain is the same for the same reason. The same force, the same acceleration, the same velocity, and therefore momentum the same, kinetic energy the same, huh? Work done also the same. So the answer, the thing that is different is the potential energy. Okay?
Okay.
Potential energy. Answer A. Okay? Because other thing, kinetic energy, momentum, work, they do not depend on the gravitational field strength. They only depend on the force, and the force we exert also does not depend on the field strength. Okay?
Okay.
Question 5. A mass of the full bottle of cooking oil is 1.3 kilograms. When exactly half of the oil has been used, the mass of the bottle plus the remaining oil is 0.9 kilogram. What is the mass of the empty bottle? It is a simple problem. I think you can work out the solution yourself. Uh, 0.4. The difference between 1.3 and 0.9 is 0.4. 0.4 is the difference between 0.13, the full cooking oil bottle, subtract the 0.9, the half bottle. So this difference, 0.4, is the mass of half the amount of oil, and therefore the total amount of oil is 0.8 kilogram. Okay, the whole amount of oil in the bottle. So the mass of the empty bottle is 1.3 minus 0.8, which is 0.5, right?
Yeah.
Full oil is 0.8 kilogram. 0.4 is the mass of half the amount of oil.
Mm-hmm.
And so finally, take the total mass here, 1.3 kilogram of the bottle and the oil, and subtract the mass of 0.8 kilogram the oil. So the mass of the empty bottle is 0.5 kilogram, not 0.4. Okay. It is a simple problem. I don't think that you can make a mistake. Question 6. A solid ball has a volume of 4 centimeter cube. The density of the ball is 1.6 gram per centimeter cube. What is the mass of the ball? Just do one equation, huh? The relationship between density, volume, and mass. The question, the mass is the density multiplied with the volume. Mass is density multiplied with the volume, huh? Density is 1.6 multiplied with 4. 4 times 6, 24. So it's 6.4, huh? 6.4 grams. We can like do the calculation in our brain without a calculator.
Yep.
Okay. Question 7. Extension, meaning and over the load graph, meaning the vertical axis is extension, horizontal axis is the load, meaning the weight of the object that we hang to the spring. Also means the force that extend the spring. And we have a linear straight line graph. The unstretched length of the spring, we can call it the natural length of the spring, is 15 centimeter. When an object, a known weight, is suspended on the spring, the length of the spring is 16.4 centimeter. What is the weight of the object? Do you have an idea how to find the answer of this question? What can we calculate from the graph?
The gradient.
The gradient. And what does it mean, the gradient? Meaning, how do we calculate the weight of the object hanging to that spring? Do you remember this equation? The force equal the spring constant K multiplied with the extension. X here extension. And K here is called the spring constant. Do you remember it? Spring constant. If you don't, it's fine. Just open the formula sheet and see where it is, huh? Yeah, it's called Hooke's law. Hooke's law. Force, elastic force is kx proportional to the extension x, and that k is the spring constant. The spring constant means the force to make the spring extend by 1 meter. The force that makes the spring extend by 1 meter. Okay, and we have this graph x versus f. So the equation from this equation, x is f over k. So the gradient of this graph, the slope of this graph is 1 over k, not k. Okay, this is a difficult question. Do you get it? The reason why the gradient is 1 over k? In mathematics, you learn a equation y equal mx, right? Straight line. M is the gradient of this straight line graph, right?
Yeah.
So this relationship x equal, instead of writing f over m, I can write f over k, sorry. I can write 1 over k multiplied with f, F here is like the variable x because it is on the horizontal axis, the load. It is like x in this general form. and y here actually x. Okay, so the thing 1 over k here is the m, the gradient. Okay,
Okay.
the gradient. So the gradient is 1 over k. Please calculate that gradient and then calculate k, and then the weight of the object. And the answer of this question, the weight of the object is that inverse of the radian, k times x. K times x. X is x is 16.4 minus the unstretched length, the natural length, which is 15 centimeter. Okay, and you need to convert this thing from centimeter to meter by multiplying with 10 to negative 2. Okay, and k is 1 over the gradient. So you need to calculate the gradient first. Okay, this is a difficult question. That's strange. Yeah, sometimes there must be some difficult question like this for student getting A or A star. Can you calculate the gradient?
Yeah.
The gradient is 205, correct? So 1 over gradient is 2.5, correct? Well done. And multiply with 1.4. Kind of difficult. Are we allowed to use the calculator in paper 2? I think we are, huh? Allowed.
Yeah.
Yeah, so you can use the calculator. 2.5 for the value of k, multiply with 16.4, subtract 15, and remember to convert to meter, dividing 100. 0. Wait. My calculation. Wait. Centimeter, the gradient. Oh, okay. We don't need to multiply with 10 to negative 2 here because the gradient were already calculated by the same unit, centimeter, huh? Centimeter. Meaning we need 5 Newton force to make the spring extend by 2 centimeter. So there's another way. Actually, there's another way that you can calculate the force without calculating the gradient. A lot faster than calculating the gradient. You just need to look on the graph where the extension is 1.6 centimeter and locate the force necessary for that. 1.64. 16.4 minus 15 is 1.64, huh? Yeah, that place. This is 1.6. 1.64 is like in the middle here, and then you draw a line a little bit above, huh? Not that line here. Okay, so the force is about 4 Newton. Wait. 4.1 here. 4.1, huh? So the answer is 4.1.
Well, why did 5 come out?
Huh?
There was another answer of 3.5.
When we calculate with the gradient, huh? 16.4 minus 15 is 1.64, right? 16.4 minus 15. 1.4, sorry, my bad calculation, a terrible calculation. It's 1.4, sorry. It's 1.4, huh? And therefore 1.4 is here. Just draw a line here. There. That exactly 3.5, huh? So this way is a lot faster than calculating the inverse gradient, huh?
Okay.
A lot faster, huh? Just use the graph. Go down. There. 3.5 newtons. Question 8. A box of mass 2 kilogram. Again, the graph here means we need 5 Newton, to make the spring extend by 2 centimeter, or 2 Newton to make it extend by 1, no, not 1, by 0.8 centimeter, That's the meaning of this graph. Question 8. A box of the mass 2 kilograms is pulled across the floor by the force of 6 newtons. The frictional force is 1. What is the acceleration? You need to take the force 6 Newton pushing it, subtract the frictional force 1. It means the resultant force is 6 minus 1, which is 5 newtons, and then 5 Newton force divide the mass. A acceleration is F over m, A is F over m. So 5 Newton resultant force divided by 2 kilograms, the acceleration is 2.5 meter per second square. Okay. The point is the resultant force is 6 Newton minus 1 Newton frictional force. Writing with the finger. Okay, 2.5 meter per second square. Question 9. Which moving body has the resultant force acting on it?
D.
An aircraft circling an airport at a constant speed has the resultant force.
D.
You said D. A parachutist descending vertically at terminal velocity. Terminal velocity means the velocity is constant, and constant means acceleration is 0. So the answer is not D. Think again. It is B. An aircraft circling an airport at a constant speed, circling, moving around, almost in a circle. You know, sometimes airplane must fly around around a city because the airport is so crowded with different other airplanes, or because of an accident or something happening on the airport. So the airplane must go around and around waiting. Okay, if it is about to run out of the fuel, it has to choose another airport to land. Okay, and it happened pretty often in this Saigon City airport, especially in third holiday, And when circling, moving in a circle like this, there is a force, the resultant force acting on the airplane is pointing toward the center, and that's called the centripetal force. Centripetal force. Okay, the answer is B. So I see that you need to review a lot about mechanics. Like the beginning, the first topics that you studied like last year, The recent topic like FPI, transformer, and magnetic force, you did it very well, and even some part with electric circuit. But we do need to review carefully about these kind of questions about acceleration, resultant force, centripetal force. You get it? Aircraft, answer B, Any question?
No.
Okay. Question 10. Let's read it and choose an answer.
A.
Force is a change momentum divided by time taken. Correct. Well done. Accelerating to speed 25 from 20 to 25 will increase in kinetic energy. Tell me, how do you calculate that increase in kinetic energy?
Because the curve, the mass would be the same. You have to work out the kinetic energy for speed, for when the speed is 20, and also when the speed is 25.
Yes, I've written the red equation there. That is the final kinetic energy. Subtract the initial kinetic energy, huh? With 1/2 m is the carbon factor. Now you can use the calculator to write it, to calculate that. Kinetic energy is 1/2 mv square.
But don't calculate it separately.
Not that big. Do the calculation again. The formula here.
It says 100. Oh.
Yes, and then you round to 170 kilojoule. Kilojoule means 1,000, huh? 170,000 joule. The answer is C. Answer C.
I get it.
12. Again, we've seen this question like once or twice, huh? Remember?
Oh.
The answer is wait. No. It seems familiar, but not exactly the question that we've done. Use the production of steam to generate electricity. Steam, that is nuclear power station. They use the heat dissipated by the nuclear reaction in the reactor to heat up the water and form the steam. Hydroelectric is simply used the flow water from a dam, okay, from a dam flowing out through a channel. Tides and weight, also the similar principle, the difference of the water, the height of the water stored in a dam. The answer of question 12 is nuclear. So if you look for some photo of the nuclear power station, huh, you see giant, what's it called? Power plants, like this thing, you see? A lot of smoke. Actually, those are the vaporized, the steam. They use the heat from the nuclear reaction to boil up to make the steam, okay? It look marvelous, huh? Answer the nuclear B. 13. A car traveling on a straight horizontal road, 1.6 megajoule of kinetic energy. It accelerates for 20 seconds until it has 2.5 megajoules of kinetic energy. What is the average power output used to increase the kinetic energy of the car? What does it mean by power? What is the equation of power? You can open the formula sheet and check it. Tell me the equation to calculate power.
Work done over time taken.
Exactly. And sometimes the work is the same as the increase of energy. So the way to answer this question is to take the increase of energy, final energy minus initial energy, and divide it by the time. The question is the power output, meaning, okay, you need to subtract the energy, 2.5 megajoule, subtract 1.6 megajoule, and then divide the time, 20 seconds. Note that this is megajoule, not normal joule, 1 megajoule means 10 to the power 6 of a joule.
Okay.
10 to the power 6. 1 million joules. So what is the answer?
D.
I'm checking it. 0.9 times 10 to the power 6 and divide 20. 45,000, meaning 45 kilowatt. Correct? That is C.
Oh my God, what is this? What?
Watch the diagram show after exerting least pressure on the ground. Very easy, huh? Least pressure. What is the equation for pressure? And what does it mean by pressure?
Oh, that P times V is constant.
Pressure is force over area. How much force acting on a unit area? How much force on 1 meter square? The smaller the area, the greater the pressure.
So
Standing on 1 foot, greatest pressure. Okay,
it's B.
greatest pressure. So lying down here will produce the least pressure.
Yeah.
So if you stand for too long, not only you feel tired of your muscle on your knees and your back, but also feel pain at your feet, because of great pressure there. 15. The diagram shows a U-tip manometer containing 3 liquids. X, Y. Neither liquid X or Y mixes with mercury. Mercury at the bottom, huh? Which role compared the pressure exerted by the liquid X and by the liquid Y on the mercury, and the density of the liquid X and the density of liquid Y? Seems complicated problem, huh?
D.
Pressure the same, density. Pressure the same is the correct answer, and we see that liquid Y has a lower height, but producing the same pressure. It means it must have greater density, huh? Y has greater density. Density Y greater. Correct. Well done. Yeah, that is B. 16. Gas molecule exerts a pressure when colliding with the wall of container. Which statement is correct? What do you think? Question 16.
I think it's D.
D. Experience a change in momentum in which exerts a pressure equal to force over area on the wall. Change with pressure. Exactly, that is D. It's that D. 17. Thermometer. What is the lower fixed point and what's the upper fixed point? Graduation. We start minus N naught.
Isn't it all 0 and 10, 100?
I think the lower fixed point is 0 and upper fixed point 100.
Yeah.
I agree with your answer, huh? But let me find a mark scheme somewhere to check it. 1, 2. This is March, huh? March, not June. Okay, next time we do the June paper. Mark scheme here. Question 17, huh? C. Yeah, exactly. 0 degree and 100. The normal fixed points for a mercury thermometer, huh?
This will not ever change, right? Would it change? Would the lower fixed point and the upper fixed point ever change?
The lower fixed point is the freezing temperature of water, which is 0 degrees Celsius, and the upper fixed point is the boiling temperature of water.
So in any occasions, it would never change.
Depend on the question, depend on the given type of thermometer, but most of the time it is 0 and 100. Huh?
Okay.
18. 1 kilogram block of aluminum requires more thermal energy to raise its temperature by 1 degree Celsius than the 1 kilogram block of copper requires. What is this?
B.
Aluminum poor conductor? No. The answer is it requires more. Aluminum require more thermal energy to raise the same temperature 1 degree. It means it has higher specific heat capacity. Specific heat capacity, answer C. The equation of this specific heat capacity is E equal mc delta T. Remember, you can open the formula sheet, check it again. This C is the specific heat capacity. Okay. Looking for that formula in this sheet. Here. Thermal, about the thermal topic. Specific heat capacity means how much thermal energy required to raise the temperature of 1 kilogram substance by 1 degree Celsius. Okay. Can you repeat that? The definition. We do need to memorize something, huh? Especially in physics, the concepts like what is acceleration, what is specific heat capacity. Let me repeat it one more time and you will repeat after, huh? Specific heat capacity is the amount of thermal energy required to raise the temperature of 1 kilogram substance by 1 degree Celsius.
The amount of thermal energy required for
to raise
the temperature by 1 degree.
By 1 degree to raise 1 kilogram substance.
Of 1 kilogram substance.
For example, in this case, aluminum requires more thermal energy than copper. It means aluminum has greater specific heat capacity compared to copper. Okay, it's easier for copper to be to increase the temperature to get hotter compared than aluminum, huh?
Okay.
That is the reason why in computer and in some cell phone they use copper as the heat dissipation part, what's it called? Heat dissipation in laptop, for example, huh? Here, you see, they use these copper bar to conduct the heat from the CPU to the fan, and then use the fan to blow out the heat, the hot air. Okay.
Okay.
And they even put some special liquid inside these copper tip to help transferring the heat faster, more effectively. But that thing, the conduction of thermal energy is conductivity, not specific heat capacity. Question 19. 4 campers are warming their food on fire. They use different rods, each of them dimensions to hold the food near the fire. Which material is best choice to prevent their hands from getting too hot?
D.
Wood. Yeah, exactly. D. Metal. Metal is a very good thermal conductor.
Yeah.
Question 20. Hopefully that if we try hard enough, we can complete this paper. 40 questions in. There are 20 more questions to go in half an hour. Huh? 2 metal can be identical, except that one has a shiny silver outer surface, and the other has a dull black outer surface. They each have 300 grams of water at 80 degrees Celsius sealed inside them. They are both in vacuum in the darkness of outer space. How does the temperature of the water in each one change?
The water in black. B.
Water in black can cool more slowly. No, actually, it's more quickly. You forgot the explanation about I showed you last time, right? The pen, the white pen, remember, and black, the 2 bottle, black and white color thermal heat absorption emissions experiment. Last time I showed you some video like this, huh? Absorption, visit about absorption, looking for the emission. Emission. Black and white. Last time I showed you similar experiment like this one. Do you remember? Exactly this one.
Wait.
After a certain time interval, the temperature of the hot water contained the black body, the black bottle here will be lower than the temperature on the white bottle, because the dark color, the black color, emits the thermal energy faster than the white color.
Okay.
You forgot it, huh? Only a few days ago. The answer is in the shiny can cools down more slowly than in the black can. And also the drop surface emits the thermal energy also faster than the shiny and smooth surface, huh? But when making things like a car, we do not want our car to be dull, to be rough, and we want it smooth and shiny. Question 20. The diagram shows the water on the way before it reflects from barrier. Which label section in the diagram represent the wave front? Okay, what's your answer? Which one, A, B, C, D, is a wave front?
A.
It is C.
But doesn't C just show the wave and not the wave front?
Each vertical line here, each one is a wave front. Wave fronts. What does it mean? Let me find a picture to illustrate that. A wave front. Here, a wave front is all the points having the same phase, the same displacement, the same energy, the same velocity. And normally we take the peaks. How do I reduce the size this one? Cannot do that here. Wait. I cannot reduce the size this one. That's so weird. Okay, okay. Choosing it. Not resize it. Okay, so put it just somewhere else. Huh? It is C. We usually choose a. Let me take a screen. The peak of a wave to be the wavefront, huh? Wave area. That's so strange. I cannot make it smaller. Oh, here now. Okay. So each vertical line here is a wavefront, and the distance between two successive wavefront, this distance equal to B here, huh? Is called a wavelength. Okay, this distance is a wavelength denoted by the letter lambda. Okay.
Okay.
Wavefront. 22. Vibrating object produces a ripple on the surface liquid. The object completes 20 vibrations every second. So spacing the ripples from one crest to the next is 3 centimeters. What is the speed of ripple? Spacing from one crest to the next, it means this number is the wavelength lambda. What is this thing? Lambda. It looks like the X letter. Okay, lambda.
Yeah.
Frequency multiply with wavelength.
C.
Yeah, I think it is that thing. C. 22, huh? Yes, it is C. 23, please. Angle of reflection. (1.5) equal sine of the incident angle equals sine of 40. Correct? That is the correct equation. Just find the angle. And then you need to do the inverse sine, huh? To find the angle.
Oh, wait, can I just use my calculator?
Yes, yes, you can put it into the calculator. the angle when of the refracted ray to the air will be will make a greater angle compared to 40, huh? Like this. This angle must be greater than 40. That is the refracted angle R must be greater than the incident angle 40 degree here, because the air has lower refractive index compared to the liquid, which means the light transfer faster in the air compared to in the liquid, huh?
Yeah.
So sine of that refracted angle R is 1.5 multiplied with sine of 40. And then after doing the multiplication, you need to calculate R by the inverse sine of 1.5 times sine of 40 degrees, 75. 23 is correct, 75. Well, good job. 24, the diagram correctly represents the rays of light passing through a converging lens in a camera. The correct diagram is A. The line passing through the center of the lens here will go straight, huh? Remember that thing. And the image form is inverted, upside down, huh? Inverted. And it is a real image and smaller. This image is placed on a sensor. I forgot the name of that thing. And the greatest brand company making that sensor is called the either Sony, huh? Recently, almost all the flagship phone like iPhone, Samsung S, Samsung Note, they use the sensor made by Sony. What's that called? CCD sensor for camera. The function of this thing, yeah, CCD, is to transform the light signal, huh? The light coming from the environment to this sensor through the lens, focused by the lens onto this sensor. The light will be converted into the electrical signal, a lot of signal, and then transferred to the processor to transform that signal into a digital photo. Okay.
Okay.
So the answer is A. The light must go through the center of the lens, forming a smaller and real and inverted image. Question 25, the speed of X-ray in vacuum and in the air.
C.
No, answer is D. The speed of light in the air is almost the same with the speed of light in vacuum, which is 3 times 10 to the power 8, huh? A very famous number, huh? Almost the same with the vacuum. 26, a sound wave passing through a point, the air pressure, that point increases and then decreases 300 times every second, meaning visit the frequency. Which description applies to this way?
B.
Longitudinal. Yes, sound wave is longitudinal. Within human hearing range, 300 times per second, meaning 300 hertz, and that is within human hearing. Human hearing range is from 20 hertz to 20,000 hertz, huh?
Yeah.
And I remember a time I showed you that we can measure the frequency of our voice, huh? Measure frequency of a wave online with a calculator period. with microphone. Microphone sound analyzer. One pitch detector is a flat pitch of any sound. Okay. I showed you this thing once, huh? Okay, do it again. No, do not press the play button. Wait. Frequency, where's that? No, the peak here, huh? 66. This is amplitude, the frequency here, kilohertz. The lowest peak, here is my, what's it called, the basic frequency, because our voice is made of many frequency, and the frequency will be multiple times of each other, meaning the second peak here is twice of the first peak. We just only need to focus on the first peak, which is this one. And what is value? 0.14 kilohertz, meaning about 140 hertz. That is my basic frequency. Okay.
Okay.
You can test your frequency of your voice with this thing. Just note the first peak here. We see the spectrum of my voice. And the distance in time between the two peaks is the frequency. No, the period. Frequency. Okay. Do it again. This thing 428. You see, double the basic frequency 14 last time. Okay. 27. A boy stands on 100 meters from a wall. He claps and hears echo. He immediately claps again. He continues some time. Another student has a stopwatch. He stopwatch the first clap and stop it on the 11th clap. The watch reads 10 seconds. Which value do her measurement give the speed of the sound in the air? Think about it, huh? Determine the period. And then take the distance, divide the period. You get the speed. Start the watch on the first clap and stop it at the 11, meaning there are 10 claps, 10 periods between the clap. 1, 2, 3, 4, 5, the period. So it means that the period T, the period, is 10 divided by 10. 11 clap, but that is 10 times 10 interval, not 11 interval, okay? Which means the period is 1 second.
It's just 8.
This is the distance. No. It probably is more complicated than that, because the speed of sound must be about this thing. Or if you just remember this thing and answer without any calculation, huh? Just remember result. He hear an echo, immediately clap again. Okay, he will clap again when he hear an echo. So this is not the period of the sound he produced, but the period between the two claps, meaning the time interval for the sound to travel from. Wait. It's not D. The answer will be C. The reason is because he claps again immediately when he hear the echo. The sound from him here, standing clapping and hear the wall. The sound travel from his hand to the wall and reflect back. And the whole time that travel back and backward reflected is 1 second. 1 second, meaning the time for one travel is 0.5 second. Okay, moving twice takes 1 second. So the time for one round from his hand to the wall is half of that, 0.5 second. Okay, And the speed is the distance divided by that time, which means 150 meter divides 0.5. So it is 300 meter per second for the speed of the sound. Huh? So this is the simplest way to measure the speed of sound, but of course it has a lot of error and uncertainty. Checking the answer, 27. C, yeah, 200, and that is a solution. Huh? Remember to divide the time 1 second by 2, because the sound traveled twice from him to the wall and to him again, and that time for traveling twice is 1 second. Okay, you got it, right?
Okay.
The end of the 3 metal rods are tested by holding Q of one rod close to the others in turn. The results as follows: N, Q attract, N's are, okay, so these things are the magnets or a metal bar among the 3 rods. Determine it. Read the statement carefully, huh? Think about it.
Only 3?
Which of the metal rods is a magnet? The NQ attract the NR. Q attract R. This is like repulsion, okay. So Q could be a metal rod. Could be, not definitely, huh? The NQ attract the NS. Attract S also, attract R also. So this thing definitely a metal, not a magnet, because a magnet only attract one pole and repel the other pole, huh? The NQ attract the NT and repel U. The NQ attract T and repel U. Wait, so it's now the metal thing is, okay, so the rod 2 here could be metal. Yes, definitely metal. This one is a magnet. Magnet, and this thing also magnet. So the rod number 2 in the middle is the metal. Which of the metal rod is a magnet? Meaning the answer is the rod 1 and 3. 1 and 3, answer C. You got it? The rod 1 can attract and repel T and U, the 2 pole. Attract or repel the 2 poles. So they are, the rod 1 and rod 3, both of them must be magnet. And the rod in the middle, the rod 2 is simply just a metal bar because it is attracted in both ends. Huh?
Okay, I get it.
Very simple. It's just like for secondary school. But among 40 questions, there must be some easy question like that. Huh? It cannot be like all 40 very difficult questions. 29. Metal sphere charged by induction. There are 4 stages in this process. Read it carefully. Okay, let me read that. Which before carried out. Charge transport near the surface, charged by induction. Are you sure that you really understand the meaning of this process?
No.
Okay, let me show you the experiment. So you're just choosing randomly, huh? Charging by induction. Okay. Hopefully that this experiment is clear enough, huh? Can you hear the sound from this video? Anyway, I will explain it. Induction, okay. Here are 2 metal spheres, and they are separated. They are not in contact, okay? And he's using a wool or feather, something from, you know, the hair of animals or just wool, and he's rubbing this wool with this plastic piece. Yeah, rubbing like that, plastic piece. The rubbing process, the friction, will make the electron transfer from the wool to this plastic piece, and this piece is now charged. negatively charged, okay, or can be positively charged depending on the electron moving from where to where, probably from the plastic to the wool or the other way around. But anyway, the plastic piece here is now charged. And now we will move this charged plastic piece to the sphere. Pretty close, but not in contact, huh? Not in contact. Wait, that's difficult to explain this thing. I think this is like a more complicated experiment compared to the normal process that I am looking for here. Charging by induction. Firstly, we rub a plastic rod with wool or with clothes in a dry condition, dry with low humidity. Low humidity in our room, the humidity should be lower than 60%. When we drop a plastic rod, such as a ruler, on with our hair, a balloon with our hair, without clothes, the balloon and the plastic rod will become charged. For example, in this case, it is negatively charged. The next step, we bring this negative charged rod close to another metal object, the sphere here, okay? The negative charge will actually repel the free electron on this metal sphere. Those free electrons are pushed by this negative rod to the opposite side, further away from the rod, okay? And therefore, the side on the left here, closer to the rod, is positively charged because of the lack of electron, okay? The electrons are on the right side here, and the left side lacking electron becoming positively charged. The next step, we connect the right side with more electron here to the ground. So the electron can escape the metal sphere and move to the ground, okay? By the conduction, by the electric wire, allowing the free electron to move from the sphere to the ground. And finally, we disconnect the wire from the ground. After disconnecting the wire from the ground, now the sphere's a lack of electron. They do not have the same amount of electron and proton, lack of electron, and therefore the sphere is now positively charged. Even when we bring the rod away, it is now charged because the electron has left it to the ground. Okay?
Okay.
So that is the process of charging by induction. The first step is bringing a charge rod near the sphere with the first step. The sphere Earth, the second step. The charge rod taken away, the Earth connection is removed, the third step, and finally the fourth step. Okay, so the order is W, X, Y, Z. W, X, Y, Z. Answer B. Wait, W, X, Z, Y. X, Z, Y. Answer B. W, X, Z, Y. You got it right. You can watch the video here again if you still confused. Okay. 30. Which electrical quantity is defined in terms of energy supplied in driving charge around a complete circuit? Energy supply in driving charge around a complete circuit. Complete circuit. It is the EMF, electromotive force. In other terms, electromotive force, EMF, is the energy that the battery must provide to push unit charge, which means 1 electron, 1 coulomb, a complete cycle in an electric circuit. You get it? The meaning of this EMF?
Yes.
And you can put it, this thing translate to Korean in case. And recently, have you heard of the thing called the ChatGPT?
No.
It is a new artificial intelligence. It can do a lot of things when we give it the like questions, translate this into Korean. Let's try,
Okay.
There. Is it a good and accurate translation? I don't know.
Oh, okay, I get it now.
Do you understand the sentence here in Korean? I don't know if it is good enough for doing the translation.
Okay.
Okay, let me ask another question. Explains simply what electromotive force is. What electromotive force is? Okay. Electromotive force, EMF, is the energy per unit charge provided by a source such as a battery or generator to push electric charges through a circuit. It is not actually a force, but rather a potential difference of voltage that causes electric charge to move through a circuit. Basically the same idea, but just longer expression, Normally, I usually simplify the definition by a short sentence like this so that students can easily memorize and understand than a very long definition. And normally, you use the unit volt. We have the equation. The current is the voltage divided by the current, the resistance. B here is the voltage, which is the soft term for potential difference. And potential difference is very similar to EMF. It is the energy per charge. Energy per charge to push unit charge. So 1 volt is actually 1 joule per 1 coulomb. Okay.
Okay.
1 joule per 1 coulomb. Anyway, we'll keep practicing with paper 2 and paper 4 next week. I think that is it, enough for today, There's like 10 questions left. We do it next time.
Okay.
See you later.
Bye.
Have a good weekend.
You too.